Okay guys, so next I want to show you just or reiterate how you calculate the other central tendencies and measures of dispersion, those ones we discussed which were useful for data that is skewed. So I'm talking about the median, interquartile range and range. Okay, so I'm just going to get rid of this panel right here and move our chart over to the side for now. The rest you can just leave as is. So if you remember, the median, interquartile range and range are all determined from a data set that has been ordered ascendingly. Okay, so first of all, in order to determine these numbers by hand, we need to reorder our data set. Okay, so what I'm going to want to calculate with you is for the two different types of calculations or counts that we've got here. So we have trees with ivy and we have trees with no ivy growing on them. And we want to calculate minimum, Q1, or the 25th percentile, median. We want to calculate Q3, or the 75th percentile, and we want to calculate the maximum. Those are the elements that we need in order to have the range, interquartile range, and median, all the elements which are shown in a box plot. And we want to calculate all of those for the trees with and without ivy growing on them. Okay, so in order to do that, we want to have them, each of these columns ordered ascendingly. And we have to do that one after the other, because obviously, because one group has potentially counted the least amount of trees, so they might have the minimum number of trees with ivy, they might not also have the minimum number of trees without ivy growing on them. You'll see what that means in just a second. So in order to resort the data, I'm just going to highlight everything in the data range, except for those calculations we did at the bottom there, okay? So that's the range you want to highlight. And then we go to sort and filter. We're in the home tab, okay? Custom sort. And first we're going to order or sort the data by ivy from the smallest to the largest value. Okay. So from that we can see that the lowest amount of ivy trees counted by any group was 25. So that's our minimum. We can also see, if we scroll down to the bottom, that the maximum number of ivy trees counted by people was 162. That's the biggest value, which is the one right at the bottom. That's our maximum. Okay, so that was easy. The median number is the one which is right in the middle. And if you remember from the lecture, we can calculate the position of the median by taking the sample size plus 1 and then divided by 2. Okay, so first of all, we want to know how many cells do we actually have here. How many groups collected tree data? And if you remember, you do that by highlighting all of the cells. And then you can see down here, there's a count of 35. Okay, so in order to find out the position of the middle, okay, so I can do that down here if you want, median position, we need to take the number of trees we've got. So 35 plus 1, which is 36, divided by 2. Not the number of trees, the number of groups who've counted trees. Okay, so 35 plus 1, which is 36, n plus 1 divided by 2. So that gives me the position 18. Okay, so I can look now from the first entry of ivy tree growth calculations, and I'm following the count. If you have a look down here, you can see the count sort of increasing, so you can stop when you hit 18. Okay, and position number 18 is this cell right here. It's row number 19, because obviously we have to add the headers at the top here. Okay, the actual data starts in row number 2. So 18 rows down, that's the position of the median for the trees with ivy. I'm just going to highlight this in yellow, okay? And I'm going to write that down here. So the median for this data set is 68. Okay. Now, next thing, we want to know Q1 and Q3. And if you remember from the lecture, those are the middle numbers in each half of the data set. And because we have here an odd numbered data set and the median falls on an actual number rather than in between two numbers, we just exclude that number, the 68, this position here, and we look at the median of this half of the data, and we need the median of this half of the data, and that gives us Q1 and Q3. Okay, so let's start with this one. We have 17 cells. Okay, so the middle position is, as we did before, 17 plus 1, which is 18, divided by 2, which is 9. So we're looking for the 9th position, the 9th number in this row, and that's right here, position, or cell C10. And the value here is 40. Again, I'm just going to highlight this, and this time I'm going to highlight it in blue. So Q1 for the trees with ivy growth is 40. And I'm going to do the same for down here. Okay, so the number of cells should be exactly the same, and it is 17 because we split the data set in half with the median. And so I'm looking again for position number 9. I go down. This is the 9th cell right here, 83. Okay, so these are all the values that I would need in order to produce a box plot for all the trees with ivy growing on them. Now, what I'd like you to do now is reorganize the cells so that you have no ivy in ascending order, and then determine these values for that data. Okay, so I'm going to highlight cells just like I did before, all the way down to the last count down here. Sort and filter, custom sort. And now I'm going to change my selection to no ivy. Press OK. And now what I want you to do is again determine minimum. In this case, that's the first number up here because we've ordered ascendingly. So that's 17. Maximum. Down here, the maximum is 87. And then I'd like you to give me the median, okay, middle number in the data set. And because you have the same number of entries, the same sample size of 35, just like you did before, okay, highlight them all, it's still 35. You're looking for position 18, and then within each half, you're looking for position number 9 for these values, okay? So find these out just like you did before, and then tell me the answer. Okay guys, so hopefully you have the same result as me, which is that for these trees with no ivy growing on them, the median is 40. Q1 was 33 and Q3 was 51. Now that you've done this by hand, I'm going to show you what formulas Excel has in store for you to do this much quicker. Okay, so we'll do exactly the same as before. We want the minimum, Q1, median, Q3, and maximum for these two types of data, for these two variables. Okay, so trees with ivy and trees with no ivy. The formula in order to get a maximum of a selection of data in Excel is called, the minimum in a selection of data is called min. Okay, we open the bracket, we highlight all the cells in the range, close the bracket, press enter. And as we determined before, it's 25. And hopefully you remember correctly how we get the same for no ivy, simply by dragging the formula over to the right, and then we get 17, the minimum of this selection right here. Maximum, just as simple, it's max, open bracket, make your selection, close bracket, press enter. Just like we determined before, it's 162, and we drag it across, and just like we determined before, 87 for the trees without ivy. Median, very simply, equals median. That's one way of doing it. I'll show you another way in just a second. Highlight the cells again, close bracket, press enter. The median is 68, just like we determined before. Drag it over, and it's 40 for the other, for the trees without ivy. Quartile function. It is called quartile. Okay. Now there's a few different options, and you'll see that the original function has actually been made redundant. It only really works for Excel 2007 and earlier. What we're going to use is this one here. The difference between these two functions is just whether or not you include outliers or not. So just use the quartile.exc or excluding function. We can just double click that, and then it gives us prompts as to what it wants. Okay, so the first thing it wants is the array. That's the selection. Okay, so we select the cells we want the first quartile of. Then the next thing it wants is a comma, and then it wants which quartile. If you press 1, it'll give you the 25th percentile. If you specify 2, it'll give you the median. That's the other way of calculating the median. And if you press 3, it'll give you the third quartile or 75th percentile, which we'll do later on. In this case, we want 1. We close the bracket and hit enter, and we get the same result as before, which was we determined it as 40. We drag it across to see for no ivy, and it's 33. We can do the same down here, so let's do this again. Quartile, double click, it opens the bracket, highlight your selection, press comma, and then in this case we want 3, okay, the third quartile or 75th percentile. Close bracket, press enter, and it's 83, just like we saw before. Drag it over, and it's 51 for the trees without ivy. Okay, so Excel has these functions, and again, if you know how to use it, it makes your life so much easier. What we can do now is we can create a box plot, and it will essentially create a box plot using exactly these values, just like we did. Okay, so let's highlight these 2 rows. That's just like we did before for any graphs that we want to insert. Okay, we only want the data and the headers for the data. We go to insert. Now the box plot is not one of the charts which is sort of on the sort of shortcuts at the top here, but we can also always go to this little arrow down here which gets us to see all charts. Click on there, it opens up a pop-up window. We don't want to use recommended charts. I can't stress enough how much can go wrong when you do that. We go to all charts so that we can select which one we want, and in this case we want a box and whisker plot. Press OK, and here it is. Okay, and if you drag this down, I can just show you that it is using exactly the values that we've produced, except that it's excluding outliers. Okay, so our maximum of trees with ivy growth of 162 is here as an outlier. I showed you this in a lecture, that sometimes, depending on how things are determined as outliers, that's what's done by the program. Then it's determined the next lower value as the actual maximum in this case, or the end of the whisker, which is 128. However, it has also, that's just like we did, determined Q3, so the upper or 75th percentile as 83. Okay, if you hover over that area, it shows you the value is 83. The bar in the middle, which is the median, shows 68, which is also what we determined before as being the median for this group of of ivy trees. Then we've got the first quartile, the 25th percentile, which is 40, and we also determined that. And then we have our minimum down here, 25. Okay, and you can look at the same for this one here as well. Okay. So now hopefully you have a good understanding of how box plots work, how you determine these different values. You've learned how to calculate standard deviations by hand. You've learned loads of different formulas and a couple of shortcuts. And now there's one last thing that I want to show you, which will hopefully then clarify why we sometimes use medians and sometimes use standard deviations. And I'll do that on the Measurements tab. So once you're finished with this video, go over to that and you'll find some bits and pieces I've prepared there for you to demonstrate that.